Here is grade 7, module 5, lesson 3. Our I can statement for today is I can express quotients in different forms. So we're starting with these two examples here. You can use long division to convert a fraction to a decimal. For this particular fraction, we ended up with a terminating decimal. As we'll see with later examples, some of them might be repeating and coming from a fraction as well. But here we just divided. You have your numerator inside of our little dividing house and our denominator on the outside. One thing to remember is make sure to bring your decimal up. So don't forget your decimal. And now in 7th grade, we need to watch our signs. So always bring that decimal up. And then in your answer, is it positive or negative? Down here, we're going to write negative 14/3 as a decimal. Now, one question that I get from students is whether that negative sign can go with the numerator or whether it can go in the denominator, or does it matter, or does it go with both? The big thing with this is that it doesn't matter which one it goes on. The sign can be placed on either the numerator or the denominator. However, it can't be placed on both. Okay, it can't be placed on both, or that would change your answer. That would give us a positive answer when in fact this answer here will be negative. So we're going to do negative 14 divided by 3, or you could have done 14 divided by a negative 3. Either way, your answer is negative. So just like we set up here, we want to make sure we check our sign. And then we're going to go through and do some division. So 3 goes into 14 4 times. 4 times 3 is 12. I subtract those. I have 2. Bring down my 0. I don't want to forget my decimal. That's my other check here that we want to really make sure we catch. So I bring my decimal up. 3 goes into 26 times. So 6 times 3 is 18. Again, we're subtracting. 20 minus 18 is 2. I bring down my 0. It looks like that's going to be 6 again. And what are we noticing here? Say we kept going. It's going to be repeating. And note that the 6 is going to be repeating. So when we do that, we write our answer. We write our answer as 4.6 with a line over whatever is repeating. Okay, so our final answer will be negative 4 6/10 repeating. Okay, because this would keep going on and on and on and on if we let it. So we don't want to forget our signs. We can put that up here as well. I would like to try number 6 here, because that's going to give us another example of a repeating. So find a good amount of space. I'm going to go to another page, but have your scratch paper out and write this out on another piece of paper. All right, so here we're going to try 3 different problems. For 12 and 2/15, we have 12 is our whole number, so we can actually start putting that into decimal form. And then at that point, we're just going to figure out what 2/15 is as a decimal. So we're going to put our denominator, our 15, outside of our dividing house. And then our 2.0000, however many we need, is going to go inside. And then we need to make sure we bring our decimal up. All of this is positive, so we know right now our answer is positive. We don't have to worry about that one. But we do need to make sure we bring our decimal up. So 15 cannot go into 2. There's my 0, but it can go into 20 once. 15 goes into 20. We'll do some subtraction. 5 is left over, so I bring my next 0 down. 15 can go into 50 3 times, which will give us 45. Do some more subtraction. And it looks like we have another 50. And this is going to keep going. So how we're going to write this answer, we have to be very careful with our repeating sign because the 1 does not repeat, but the 3 does. So our final answer will be 12 and our decimals and 13 hundredths with our 3 repeating. Okay, just the 3. You don't want to put that bar over the 1 because that's saying 0.13131313, so on and so forth. This answer is just our 3 repeating. Okay, and we know that it's positive. Final answer. All right, 2/5. So we're going to have 5. 2 goes inside. We are not going to forget our decimal. Here we have 5 cannot go into 2, but it can go into 20 4 times. 4 times 5 is 20, and look at that, nice and pretty. So our answer, we had a positive here, so our answer is going to be 4/10, a positive 4/10. And no, you don't have to write the positive, but like I said on the other slide, it's nice to know that it's positive and that you're not wondering, oh, did I forget a negative? Is it positive? You just know that it is a perfect positive pair, 2 positive numbers or 2 negative numbers. Now I wanted to do this one because there's something a little different about it. The numerator here is bigger than the denominator. So you're going to do the same steps, except it's going to look a little different in that you're going to have a number. So looking at these 2 examples here, where you have that 0, 0 point, 0 point. Here, your answer will be more than 1. I'll bring my decimal up because 5 can go into 8. Only once, but it can. Do some subtraction, bring down my 0. And 5 goes into 36 times, so this is a terminating decimal. Nice and pretty. And then we have 1.6, and we are not gonna forget our sign here. We're not gonna do it because we have -8 divided by 5, or 8 divided by -5. Okay, you don't want to forget those that sign there. And because they do not match, you have a negative and a positive, your answer will be negative. Okay, your answer will be negative.